Hello, good afternoon to my YouTube viewers. Myself Jaydas. In this video, I like to discuss diffraction phenomena of waves. All the key points of diffraction phenomena are listed here. Here there are few important questions on this diffraction phenomena and few good problems will be discussed with this. The purpose of this video is to boost students preparation mode on fast track basis, because within few months lot many exams are going to come. Student needs to overview their preparation level for board and competitive exams. So, a solid study product can fulfill their target. So, this video may able to fulfill their requirements. Please share this and like this video. Let us come to the subject. Diffraction of light. The phenomenon of bending of light around the sharp corners and the spreading of light within the geometrical shadow of the opaque obstacle is called diffraction of light. Number 2, dimension of the obstacle should be comparable to the wavelength of light. Now, basic definition of diffraction due to a single slit. A parallel beam of light made to fall on a slit. The slit width is of the order of wavelength of light. Therefore, diffraction occurs on passing through the slits. Now, nth order secondary minima d sin theta equal to n lambda, where n equal to 1, 2, 3. Now, nth order of secondary maxima d sin theta will be twice n plus 1 within bracket into lambda by 2. Again n will be 1, 2, 3 onwards. Now, distance of nth secondary minima on the screen from the central maxima will be y suffix n equal to capital D n lambda by small a, and similarly nth maxima will be on the screen, that is y suffix n equal to twice n plus 1 within bracket lambda cap D divided by twice a. Now, width of the central maximum, that is twice capital D lambda by a. Angular width is twice lambda by a. Intensity maxima, that is general formula is I equal to I naught within bracket sin beta divided by 2 divided by beta by 2 whole to the power 2. Beta by 2 is pi a sin theta by lambda. Now, for fast maxima, that is I1 by I naught, ratio of intensities will be sin 3 pi by 2 divided by 3 pi by 2 whole to the power 2, that will give us 4 divided by 9 pi square. Similarly, second maxima divided by fundamental intensity I naught will be with sin pi 5 pi by 2 divided by 5 pi by 2 whole to the power 2, that is 4 divided by 25 pi square. All these derivations are not in your present syllabus, but you can know all these to face all kinds of exams. Now come to basic difference between interference and diffraction. Superposition of two coherent sources is required for interference. For diffraction, superposition of wavelets from same wavefronts. In interference, all bright fringes have same intensity and width. For diffraction, intensity decreases for increase in order of maxima, as well as width varies. Number 3, that is in interference, dark fringes are black, but in diffraction dark fringes are not perfectly black. Number 4, number of bands large in interference, in diffraction number of bands is small. These differences will help you to appear board level exams. At the same time, you can have a clear idea about interference and diffraction. Mainly two types of diffraction patterns are known, that is Fresnel and number 2 Fraunhofer. Now few questions related to this chapter. Diffraction of light discovered by, answer is Grimaldi. Number 2, to observe diffraction, the size of obstacle or slit that is required, that will be in the same order of wavelength. Number 3, X-ray cannot be diffracted due to, the reason is its wavelength is very small compared with light, so it cannot be used here. Now come to question number 4. A diffraction pattern is obtained using a beam of red light. What happens if the red light is replaced by blue light? Diffraction bands become narrower and crowded together. Question number 5. If the width of the single diffraction slit made double its original width, what happens to the central maximum of the diffraction pattern? Answer: as slit made double, so central maximum will be narrower because its value is 2 lambda by A, and intensity becomes 4 times. Thus the central maximum becomes much narrower and brighter. Come to question number 6. Diffraction pattern by a wire. On increasing diameter of wire, fringe width number 1 decreases, increases, remains unchanged. Increasing or decreasing will depend on the wavelength. Diffraction pattern of a wire on increasing diameter. Choice A is correct. It will decrease. Now come to next question, question number 8. The ratio of intensities of consecutive maxima in the diffraction pattern due to a single slit is, answers 4 choices are given: 1:4:9, 1:2:3, 1:4/9 pi square is to 4 by 25 pi square, and number D 1 is to 1 by pi square is to 9 by pi square. Answer C is correct. Already you have seen in the gist formula that key formulas are given, that in that question it is given everything. Now come to question number 9. In order to see diffraction, the thickness of the film is, which choice will be better, will be feasible? 100 angstrom, 10,000 angstrom, 1 millimeter, 1 centimeter? Of course, B will be the answer. It is still we can get fringes here, diffraction fringes 10,000 angstrom. Now come to question number 10. In a single slit diffraction of light of wavelength lambda by a slit of width E, the size of the central maxima on a screen at a distance B is. There are 4 choices. From the diagram you can see that fringe width will be twice B, C will be the answer, twice B lambda by E plus E, because you can see that E sin theta equal to lambda, or theta will be lambda by E, and that portion, that is a triangular portion, it is shown that fringe part lambda by E will be in the top as well as in the bottom. So, there will be therefore, Y will be E plus twice B lambda by E, E plus twice B lambda by E. Here E is very small, it is in the order of wavelength, whereas twice B lambda by E, the triangular perpendicular portion which is shown here in the diagram, in the top portion as well in the bottom, if you sum up it will give you 2 times B lambda by E, which is much higher than E. Actually E is supposed to be a very point in the diffraction maxima plot. Just it will come close to a very small point, and the triangular portion will be bigger, that perpendicular portion will be bigger. So, E plus twice B lambda by E will be the answer in this case. Let us come to question number 10. Why diffraction is common in sound but not common in light waves? Answer. Diffraction of wave requires slit or obstacle size to be comparable to wavelength of light in the order of 400 nanometer to 700 nanometer, whereas wavelength of sound is in the order of 1 meter, which is readily available. So, diffraction will be much more for sound waves. Come to question number 12. The cloud in sky generally appears to be whitish. Explain. Answer. Clouds consist of dust particles and water droplets. Their size is very large as compared to wavelength of light from sun ray. So, there is a very little scattering of light. Hence, the light which we receive through the clouds has all the colors of light. As a result, almost white, while reaching on our eyes, it is almost white. That is why whitish color is available. Now, question number 13. Light incident on a single slit, that is equal to 0.3 millimeter, wavelength lambda equal to 580 nanometer, cap d equal to 2 meter from the slit. Find the position of the fast dark and width of the central maximum. We understand that A sin theta will be n lambda, where n will be 1, will give first dark, first minima. So, sin theta will be lambda by A, and that will be the value that is coming by that we can calculate, find the position of the position, that means why you have to calculate 2 into 580 into 10 to the minus 9 over 0.3 into 10 to the minus 3, that will give us 3.87 into 10 to the minus 3 meter on the screen. Now, width of the central max will be double of this, because it is on the upper side of the screen as well as in the lower side of the screen, that will come approximately 7.74 millimeter. This is very large, compare it. So, come to next question, question number 14. Now, question number 14, red light generally used to observe diffraction pattern from single slit. If blue light is used instead of red light, then diffraction pattern, there are 4 choices, will be more clear, will contract, will expand, will not be visualize, all these things. Wavelength of red is greater than blue, therefore, B will be they will contract, all will come close to each other. Now, question number 15. The main difference between interference and diffraction. Diffraction due to interaction of light from the same wavefront, whereas interference is the interaction of two waves derived from the same sources, same source. So, thank you very much for good listening. In the next video, we will give problems on diffraction of light, and as well as we will proceed for polarization chapter. So, thank you very much to all of you.